Okay, so we'll continue with the next question of model question paper. Here they are asking to design DFA to accept strings of zeros and ones. That is the language starting with 01 or starting with 10. Okay, so now we have to write the DFA for this. So initially, what is the first step? We have to write the skeleton DFA. So what they are asking here, they are asking to accept those strings which starts with 01 or which is starting with 10. Those strings which is starting with 01 or 10 should be accepted. So what is the skeleton DFA for this? So first we will write to accept 0 1, right, and then 1, right, and either to accept we have to try to minimize the number of final states. So don't give another final state, the same final states which we have written previously, I'll redirect it to. So see, I have written to accept 0 1 and 1 0 separately mandatorily. Okay, if in this way, in this path if it is selecting, it is starting with 0 1, or this path if it is selecting, it starts with 1 0, followed by it can accept any number of symbols. Okay, so we have to check deterministic in the sense for each state we can give maximum, you can give those many transitions equal to the number of input alphabets. Here the number of input alphabets are 0 and 1, so each state may have two transitions, right? So q0 is having two transitions, done. Q1 is having one transition, right? But for 1, but what about 0? If we give 0, it can start with 0 0 also, it will accept the string which is starting with 0 0 also. So what we have to do in this case, don't give, we cannot give the loop with 0. Okay, followed by we have 1, and similarly q3 also you cannot give 1 because it may starts with 1 1. So we have to give loop which is having 0 and 1, so that it can take n number of zeros and ones after taking 0 1 or 1 0, which is according to our question. So the DFA will look like this. So this is about second sub question. And coming to 1b, define NFA. It is non-deterministic finite automata which is defined with 5 tuples or quintuple indicating 5 components: q, number of input alphabets, transitions, initial state and final state, where the transition mapping function is defined as from a state on taking an input alphabet it can go to 2 power q number of states. Okay, so now they are asking to convert NFA to DFA for the given automata. So as we have already studied, the steps for conversion NFA to DFA are step 1, identify the start state. Since Q0 is the start state in NFA, the same Q0 will be start state in DFA. Next, identify the alphabets of DFA. The input alphabets of NFA are the input alphabets of DFA. In NFA we have zeros and ones. So here also we will be having 0, 1. Right. Next, identify the transitions of DFA. So how to identify? Check for the states Q0. Now you have identified the start state. So get the transition Q0 and Q1. We are here using lazy evaluation method. Okay, lazy evaluation method we are using. So Q0 on taking 0, if you see the given question, Q0 on taking 0, it is going to Q0. So we have given Q0. Similarly, Q0 on taking 1, Q0 and Q1. And which are the new states we got in this case? First case, we got Q0, Q1. Right? So that state you consider. Q0, Q1 on taking 0 and 1. Check the question, you will get these states. Which are the new states we got? Q0, Q2. So in the third, we'll go for Q0, Q2 with respect to 0 and 1. We'll get this input. Again, this is also one more new state, Q0, Q1, Q2. We have taken input for zeros and ones. Got it? So this you have to continue until no new states we got. So Q0, Q0, Q2, Q0, Q1, Q2 were the new state for both the things we have written. The transition, the rest all are the states which we had previously. So stop here and write the final DFA. Right. Next, So here they are asking to find the E closure of all the states and also to convert the following NFA to DFA. So here they have given epsilon NFA. See, if it is just NFA, we would have had the transitions only. Here we have epsilon on the transitions. Okay. So now what is e-closure? E-closure is nothing but from a particular state on taking epsilon to which all the other state it is moving. So we have to consider all those states, right? So what is the difference between the previous NFA to DFA conversion and this one? Here whenever you have epsilon transition, you have to calculate E-closure. Okay, so for each transition after calculating you find out E-closure. So because epsilon transition means it is not taking any input. No, without taking any input it is traversing. So that we have to consider. So in order to identify the start state of DFA, here as you know that in epsilon, given epsilon NFA, Q naught is the start state in the DFA, E close of Q naught will be the start state of DFA. So what is E close of Q naught? From Q naught on taking epsilon transition to which all the other state it is moving, you have to note it down. Okay, so now note one thing, E close of a particular state is itself. Okay, you have to add q naught to q naught followed by on taking epsilon it is taking to q1. So I have added q1. Next on taking epsilon it is going to q2 q4. See, I have added q2 q4. Then which are the other transitions we have? We have to q7. See, we have direct transition with epsilon transition to q7. So I have added all these. So this will be the initial state, that is start state of DFA. Okay, so now after getting the start state we have to get the transition from this state. So I'll name it as A for our convenience. So now from this A you have to check for, you have both alphabets A and B. So we have to give the transitions for A as well as transition for B. So A on taking A. So Q not on taking A, what we'll get? Q not on taking A, there is no transition, null. Q1 on taking A, null. Q2 on taking A, you have Q3. And Q4 on taking A, null. Okay, Q7 on taking A, Q8. So Q3, Q8 will be added. Now, as I told you, after calculating the transition, you have to calculate E closure compulsorily. Don't forget E close of Q3 and Q8. From Q3 on taking epsilon transition to which all the other state it is moving, you have to note it down. So E close of a particular state is itself. So Q3 I have taken, Q3 and all the other states which is reachable with epsilon transition. Similarly for Q8 I have considered. Okay, so similarly for A and A comma B, transition for A you know these many states are there. On taking B to which all the other state it is going, so Q5. So E close of Q5. So from Q5 check on taking epsilon, you know one thing, E close of a particular state is itself. So I'll add Q5 and after taking epsilon transition it is reaching Q6 I have written, and it is going back to Q1. So you have to add Q1 and Q1, from Q1 you have Q2 Q4, right? Then q6 to q7 also you have q7. So these many states I will add. So E close of q5, that I, as it is a new state when compared to the previous, I'll name it as another variable C, right? So now we have completed with A, and this new state which is obtained here I had named it as B. So from that B you have to check for the transitions A's and B. So you will get Q3 Q8. Again take E close of Q3 and Q8. Similarly B on taking B, Q5 and Q9 you will get, so E close of Q5 and Q9, as it is new state again, so I will take it as D. So AB we have completed. Next consider C. For taking A and B we did, for taking D A and B we did, and for taking E A and B we did. After doing E we didn't get any new state, so stop here. Okay, it is nothing but lazy evaluation method only, but as it is epsilon NFA you have to compute E closure for each. So at last, what are the possible transitions we have written, and the transition diagram also we have listed, which is the final state here. As in NFA the final state was, in the given question the final state was this QF. Okay, so here wherever I include that QF I have named it as Q10. Wherever Q10 is there, that I'll take it as final state. See, in E I have Q10. So E is considered as final state. Rest all the transitions we have listed as it is. Okay, next coming to 2b question, define alphabet, strings and languages. You know, an alphabet is defined as a finite non-empty set of symbols. Every time in the every question we'll write alphabet is used is a comma b, or the alphabet is used in 0 comma 1. So what is this? It is a finite non-empty set. It cannot be empty. If it is empty, then there is no transitions at all. It is no more a automata. So an alphabet is defined as a finite non-empty set of symbols, and to denote this one we have epsilon symbol. Coming to string, a string is defined as the finite sequence of symbols from the alphabet. See, from the alphabets which I have specified in the epsilon, sorry, summation, so you can form sequence of characters. This is called as what? String. A string is defined as a finite sequence of symbols from the alphabet. Similarly, for language, a language can be defined as a set of strings obtained from the clean closure, right? And language of strings consisting of equal number of zeros and ones can be represented in this way. So this is all the strings which is acceptable by this problem statement we have specified in the language. So it consists of what? Set of strings.